All right, welcome back. This is 5C Part 2, which is called Rationalizing the Denominator. So rationalizing means the number can be represented as a whole number or a fraction. So right now, if you look at like number 9, the square root of 5, that is an irrational number. If you type that into your calculator right now, it's a number that will never stop and never repeat. So what we need to do is we need to make this denominator a rational number, so a number that does stop or does repeat. And how we do that? So we're going to look at our directions up here. So we have for monomial denominators, we multiply the numerator and denominator by the radical, whatever it is. So we'll start off, monomials means one term, so one term, one term. So let's start off there. So we're going to take and multiply by the radical. So this is a square root, so square root of 5. But when you multiply, we're not actually solving anything here. We're just simplifying. Simplifying, you cannot change. You can't multiply by something that's anything but 1. You have to multiply by something that's equivalent to 1. So whatever you multiply the denominator by, you have to multiply the numerator by it also, because square root of 5 divided by square root of 5 is 1. It's a weird looking 1, but it is a 1. So you have to multiply by something that's equivalent to 1 in order to simplify and not change the value of the original problem. So now I'm going to take a look at this numerator. So I have 3 times square root of 5. Nothing to simplify, nothing I can put together, so it's just 3 square root of 5, that's times. Over, now I'm going to look at the denominator. 2 square root of 5 times square root of 5. So I have 2 times 1 is 2. Square root of 5 times the square root of 5, so you multiply underneath the square root. After you multiply, your next step is always to divide. So now we're going to, simplify. Always simplify. I simplify each individual radical. So I'm going to look at square root of 5. Can I simplify it? No. So in the numerator, there's nothing to simplify right now. In the denominator, I'm going to look at that. Square root of 25. Can I simplify it? Yes, that's 5. So this is 2 times the square root of 25, so it's really 2 times 5, which is 10. At this point, now I'm going to look at, can I simplify on the outside 3 over 10? And 3 divided by 10 does not simplify, so that is your final answer. Number 10. I'm going to look at, so this is one big radical. I'm going to split this up into the square root of 8. So this is using the quotient rule over the square root of 15. I am then going to, I have to rationalize the denominator, so square root of 15, multiply by that monomial, square root of 15, square root of 15. So 8 times 15 is, so 8 times 10 is 80, 8 times 5 is 40, so that's 120 when I add those together. Square root of 15 times the square root of 15 is the square root of 225. But you also see that, if you notice, you have two 15s multiplied together. That's 15 squared. And when you square root 15 squared, you're going to get, this is going to be equivalent to just 15. So you can actually cut that middle step out by just realizing that the square root of 15 is 15 squared and square root, so that's going to end up simplifying anyways. In the numerator, we have square root of 120. We got to simplify that. Square root of 120, 12 and 10. We have, I wasn't quickly able to see a perfect square, so I'm just going to keep going with this. 2 and 5. Perfect square was, oh, it's only a 2. No, I did something wrong. What did I do wrong? So this would become 2. 3 times 2 is 6, times 5 is 30. Maybe I didn't do anything wrong. Guess not. No. Okay. So the numerator is 2 square root of 30. And then I'd look at the 2 and 15, see if I can simplify, and I can't. That fraction, so this is your final, that's not going to work. This is your final answer. Oh my goodness, what is going on here? All right, on the back we have, again, square roots. So we have square root of 7, so let's multiply by the square root of 7. We have 3 square root, 12 times 7 is 84. 84, almost got me. Square root of 7 times the square root of 7 is 7 squared, or 49, which is going to be 7. The numerator, square root of 84, simplify that. So now that's 7 and 12, 4 and 3. There's your perfect squares of 4. So this is going to end up being 2 square root of 2 square root of 21. Sorry. So we have a 3 that's on the outside already. So that 3 is going to multiply by 2 from here, down below. And then 7 times 3, what's left over, is going to be 21. In the denominator, we have 4. Square root of 49 is 7. So we have 3 times 2 is 6, square root of 21, over 28. Now we're going to look at, you always look at your coefficients, 6 over 28. Can we reduce that fraction? Yep. Divide them both by 2. Divide 6 by 2, you get 3. 28 divided by 2 is 14. 3/14, can I reduce that? No. And that is your final answer. You do not, that is not a 21 inside the square root. It is the square root of 21. So the 21 and 14 do not simplify. Square root of 21 is like 4 point something. It's not something, a number that you can simplify. All right, take a look at number 12. Multiply by the radical, the monomial. Multiply your numerator out. 28 times 3 is 25, 75, 84. Yeah, 84. My goodness. After school, my mental math is struggling. All right, break this down. Well, I just had 84, which is going to end up being square root of 84 is 2 square root of 21. So 2 square root of 21. Look at my 8 to the 6th, square root of 8 to the 6th. So how many groups of 2 can I take out of 6? That's 3, so that's 8 to the 3rd on the outside with no more a's left on the inside. In the denominator, I have the square root of a is 3, or square root of 9 is 3, square root of a squared is 3. If you would have taken a look back here, when you multiply 2 square roots with the same exact number and variable underneath, it's going to end up being the exact same thing after you square root it. Look at what we can simplify. 2/3. Take a look at that. Can't simplify that. Take a look at your variables. A to the 3rd divided by a outside the radical. We can simplify that. A to the 3rd divided by a to the 1st. You're subtracting your exponents, so that's going to end up being a squared. So I have 2a squared square root of 21 over 3. There's your final answer. Number 13. Again, I have a monomial denominator, so I'm going to multiply by square root of 2. Oh, here we have a binomial numerator, though. Hello. We have square root of 2 times the square root of 8 is the square root of 16, minus square root of 2 times the square root of 2 is the square root of 4. And then square root of 2 times the square root of 2 is square root of 4 in the denominator. Let's look what we can simplify. Square root of 16 is 4. Square root of 4 is 2. Square root of 4 is 2. Keep simplifying that numerator. 4 minus 2 is 2. The denominator is 2. Oh, and then 2 divided by 2 is 1. Looking at our next problem, square root of 12. Multiply by square root of 12. You got a binomial here, so 3 square root of 2 times the square root of 12 is 3 square root of 24. Square root of 12 times the square root of 6 is square root of 72. Square root of 12 times the square root of 12 is 144. This is going to be 12 in the denominator. Looking at what we can simplify, look at the square root of 24, break that down. 4 and 6. There's your perfect square, so this is going to end up being 2 square root of 6. You can break it down further, but it's going to be 2 square root of 6. So 2 square root of 6, 72, break that down. 16, 36 is the biggest, 36 and 2. So it's going to be 6 square root of 2, but if you didn't see that, you can break it down. There's your pair of 6s, or you can keep going with 3, 2, 3, 2. You can do that. But it's going to end up being 6 square root of 2 over 12. Then we're going to take a look at our coefficients now. So 2, 6, and 12. Can we divide them all by the same number? And we can. We can divide them all by 2. And then what is the result? We have 1 times the square root of 6 is the square root of 6 plus 3 square roots of 2 over 6. And that is your final answer. All right, let's take a look at binomial denominators. So you're going to multiply. Let's go back to the before. We're going to multiply for binomial denominators. Multiply the numerator and denominator. So again, you're by the exact same thing, by the conjugate. The same expression, but the opposite sign in the middle. That's the conjugate. So let's take a look at this. So look at your denominator. We're going to multiply by the same expression, but change the sign in the middle. That's your conjugate. Multiply by something that's equivalent to 1, which this is 1. It's a weird looking 1, but that's a 1. Anything divided by itself is 1. So let's multiply this out. 4 times 4 is 16. 4 times a negative square root of 2 is a negative 4 square root of 2 in the denominator. Multiplying this out. 4 times 4 is 16. 4 times a negative square root of 2 is a negative 4 square root of 2. Square root of 2 times 4 is a positive 4 square root of 2. And the square root of 2 times a negative square root of 2 is a negative square root of 4. So you might have to rewind me and look at that again. After you multiply, you always simplify. So we're looking at each individual term. 16, nothing to simplify there. 4 square root of 2, can't simplify the square root of 2. 16, nothing to simplify there. Look at negative 4 square root of 2, can't simplify that, but it's actually like terms with 4 square root of 2. So if I have a negative 4 square root of 2 and I add 4 square root of 2, those are actually going to simplify. And then the last, I have the square root of 4. Square root of 4 simplifies to 2, so this is going to become minus 2. So now I actually do have like terms with a 16. 16 minus 2. That's going to end up being 14. So our denominator is 14. So let's pull this together. So I have 16 from the numerator minus 4 square root of 2, all divided by 14. This is looking nice. Now I'm going to take a look at, let's do this, 16, 4, and 14. Can we simplify something there? They're all divisible by 2. Maybe more. Let's see. Divide each by 2. Oh, no, 7. Not more. So 8 minus 2 square root of 2 divided by 7. There's your final answer. All right, number 16. It is a binomial denominator, so we need to multiply by the binomial, but the conjugate. So plus 2 times 6 is 12, plus 2 times the square root of 5 is 2 square root of 5. 6 times 6 in the denominator is 36. 6 times the square root of 5 is positive square root of 6 square root of 5. A negative square root of 5 times 6 is a negative 6 square root of 5. Always those middle terms are going to simplify to 0. Square root of negative 5 times positive square root of 5 is a negative square root of 25. So now we have, let's look at each individual term. So 12, no. 2 square root of 5, nothing to simplify there. 36, nope. 6 square root of 5 minus 6 square root of 5, those are your like terms. We can simplify those out. Those will always simplify to 0 because it's 0 square root of 5, which is 0. And then the last term will always simplify also. It's always pretty cool. Square root of 25 is 5, so this is going to be minus 5. That minus is going to come down. So it's 36 minus 5 is 31. So let's clean this up. So I have 12 plus 2 square roots of 5 over 31. Can I take the... So can I do 12, 2, and 31? Can I simplify all of that? No, nothing to simplify. So this is your final answer. Number 17. I have a binomial denominator, so let's multiply by the conjugate. 1 plus 4 square roots of 2. So multiplying the numerator by 1 plus, so the conjugate, 4 square roots of 2. We have square root of 3 times 1 is the square root of 3. Square root of 3 times 4 square root of 2 is 4 square root 2 times 3 is 6. In the denominator we have, let's keep this straight, so 1 times 1 is 1. 1 times 4 square root of 2 is 4 square root of 2. Negative 4 square root of 2 times 1 is a negative 4 square root of 2. And negative 4 square root of 2 times a positive 4 square root of 2, you're multiplying your coefficients, so negative 16. Square root of 2 times the square root of 2 is square root of 4. Square root of 3, can we simplify that? So now I'm looking at each individual term. Square root of 3, nope, can't simplify that. So square root of 3 plus, can I simplify 4 square root of 6? Square root of 6, nope, can't simplify that. In the denominator, 1, nope. We have 4 square root of 2 minus 4 square root of 2. Those will simplify out. We have square root of 4 is 2. That's 2. Negative 16 times 2 is going to be negative 32. So I have this is actually going to simplify to 1 minus 32. Whoa. Which is going to end up being square root of 3 plus 4 square root of 6 over 1 minus 32 is a negative 31. This is a good answer. Typically in math, we do not keep the negative in the denominator. So what we end up doing is we end up moving the negative to the numerator, and then we distribute it in. So it'll end up being a negative square root of 3 minus 4 square root of 6 over positive 31. This is your best answer. All right, let's look at number 18. So we are going to multiply by square root of 5 minus square root of 3, conjugate. We have a binomial numerator and denominator, oh my goodness. 5 times the square root of 5 is 5 square root of 5. 5 times the negative square root of 3 is a negative 5 square root of 3. We're not done. Now we got to multiply negative square root of 5 times the square root of 5 is a negative square root of 25. Negative square root of 5 times a negative square root of 3 is a positive square root of 15. In the denominator, let's multiply all that out. Square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times a negative square root of 3 is a negative square root of 15. Positive square root of 3 times a positive square root of 5 is a positive square root of 15. Positive square root of 3 times a negative square root of 3 is a negative square root of 9. Look to see what we can combine, like term-wise, in the numerator, anything? No. So no like terms. Well, we can simplify, I believe the only one is 25. Square root of 25 is 5. So in the numerator I have 5 square root of 5 minus 5 square roots of 3, subtract 5, plus and 15. That doesn't break down, it's just 5 and 3. So no, can't simplify that square root. Over the denominator. I haven't simplified the denominator yet, so square root of 25 is 5. A negative square root of 15 plus 15 simplifies, and the square root of 9 is 3. So we have to subtract 3, so 5 minus 3 is 2. Take a look at your coefficients, 5, 5, 5, no coefficient, 2. Nothing to simplify, so that is your nothing that you can divide all of them by, so that is your final answer. I also never looked at, I should have looked at, do we have like terms? No, we don't. Nothing, no like terms at all, so that is your final answer. All right, number 19. Let's multiply by the conjugate, 2 minus 2 square root of 7. So binomial, so I'm going to multiply 3 times 2 is, I'm actually going to do this down below just so it's more room. 3 times 2 is 6. 3 times a negative 2 square root of 7, so multiplied 3 times 2 is 6 square root of 7. Square root of 7 times 2 is positive 2 square root of 7. Square root of 7 times a negative 2 square root of 7 is negative 2 square root of 49. All that is divided by 2 times 2 is 4. 2 times a negative 2 is a negative 4 square root of 7. 2 square root of 7 times 2 is 4 square root of 7. 2 square root of 7 times a negative 2 square root of 7 is square root of 49. Looking at our like terms and what we can simplify. I see in my numerator I have like terms here. I have a negative 6 square root of 7 plus 2 square root of 7. That's going to be a negative 4 square root of 7. I can also simplify the square root of 20 or 49. So let's put some stuff together. So we have square root of 49 is 7. So this is going to become 7. That's times negative 2. So that's going to end up being negative 14. So this turns into negative 14 here. We have 6 minus 14. So 6 minus 14, those are your like terms, which is negative 8. My like terms in the middle here, negative 6 square roots of 7, and I add 2 square roots of 7. So I have a negative 4 square roots of 7. And we're going to divide all of this by, and let's look at our denominator, what we have here. So I have negative 4 square roots of 7 plus 4 square roots of 7. That'll simplify. Square root of 49 is 7, so that's negative 4 times 7, which is negative 28. I have the 4 minus 28 is negative 24. So that's going to end up being negative 24. Look to see if you can simplify. Negative 8, negative 4, negative 24. I can divide them all by 4. And then I have a negative 2. Negative 1 times the square root of 7 is a negative square root of 7. You don't have to have the 1 there. Over negative 6. This is a good answer, but it's not the best answer because of that negative denominator. So what I'm going to do is I'm going to take that negative denominator, I'm going to move it up to the numerator. But when you move it to the numerator, you really got to distribute. So distributing the negative times 2 is going to be a positive 2. A negative times a negative is a positive square root of 7 over 6. This is the best answer. Absolutely the best answer. All right, let's take a look at our last problem. We have a binomial denominator, 2 terms, so we're going to multiply by the conjugate, 3 plus 4 square roots of 6. 3 plus 4 square roots of 6. Binomial numerator, so 8 times 3 is 24. 8 times 4 square root of 6 is 8 times 4 is 32 square roots of 6. Negative square root of 6 times 3 is a negative 3 square roots of 6. Negative square root of 6 times 4 square roots of 6 is a negative 4 square roots of 36. You had 2 terms times 2 terms. You should get 4 terms, and that's what I have here. So 3 times 3 in the denominator is 9. 3 times 4 is 12, and square roots of 6. Negative 4 square roots of 6 times 3 is a negative 12 square roots of 6. Cool, those are going to simplify to 0. Negative 4 times 4 is negative 16. Square root of 6 times the square root of 6 is 36. Looking to see what we can simplify. We have 32 square roots of 6, and we're subtracting 3 square roots of 6. That's going to simplify to 29 square roots of 6. At the end there, we have square root of 36 is 6. That's going to simplify. Negative 4 times 6 is negative 24. We then have, oh my goodness, this is going to work out nice. We have a negative 24 and a positive 24. Those are actually going to simplify out. It's going to be 0. So our numerator is actually going to only be, oh, that's so nice. I mean, it's not the nicest, but it's pretty nice. 29 square root of 6. And our denominator, let's take a look at what we got there. We have like terms here. We have 12 square roots of 6, and we're subtracting 12 square roots of 6. Goes away. We have the square root of 36 is 6. 6 times 16 is 96. 96. So that's going to be negative 96. So I have the 9 minus 96 is negative 90. Cool. Look at 29/90ths. Can I simplify anything? No. The one thing that you could do is move this negative to the numerator, which is only going to be that one monomial. You don't have to move anywhere else. And that is your final answer. All right. Come to class with any questions. Thanks for watching.